Hello all, thank you for joining me here. I'm Hitendri Bomble-The and I work as senior data scientist at Red Hat. And a big part of my work that I do there is building GenAI systems end-to-end. That includes handling data pipeline, agent workflows, evaluation pipelines. And this talk actually comes from a mix of the implementation, research, and seeing the systems quietly fail in practice. As you can see, the title of the talk is The Silent Crash, Why Your RAG Evaluation Metrics Are Lying to You. And the idea that I want to leave you with is this, that a RAG system can look perfectly healthy in your dashboard, but can still fail in a way that really matters. And so today, I'm going to walk you through why that happens, why the usual metrics miss it, and how to set up a better evaluation. So this is the agenda for today. So we'll walk through the traditional NLP metrics that we still rely on, like the Cosine Similarity, BLEU, Rouge. Then I'll decompose the RAG into two different problems, that is the retrieval and generation. Then we'll talk about LLM-as-a-Judge, which is very important for the modern RAG system that we are developing. Then there is equally important topic that we need to discuss, that is about the bias. So using LLM-as-Judge also has its own bias. So we'll discuss about that as well and how do we mitigate that. Then I'll talk about building adversarial test sets, because just using a strong judge is not enough. We need to also have a strong test data set for that. Then I'll close with practical tooling, that's the ragas and deep eval. Yeah, so let me start with this failure mode that gives the talk its name. So imagine you have deployed a RAG system for insurance claims, and a user goes and asks this question: who can file a claim on behalf of a deceased policyholder? And then we retrieve this context. Only the nominated beneficiary can file a claim. The legal heir may file only if no nominee was specified, subject to a succession certificate. But then our generator actually generates this answer, that only the legal heir listed in the policy document can file a claim on behalf of a deceased policyholder. Here you can see how it swapped the nominated beneficiary for legal heir, which is wrong. But our eval metrics, they show pretty high score, and everything on our eval dashboard then looks green, and we do not exactly know what failed, but in reality, something was missed. So here we see that the two legally distinct roles, they are swapped, and this might also lead to some problems, like the claim process, it actually is hindered by this, or it goes to the wrong person, or it might also lead to some legal disputes. So yeah, we need to be careful with this. Then why does this matter so much right now? Because RAG is no more just a demo pattern. We are using it in enterprise search, in internal documentation, search agent, then in medical workflows, legal workflows. So this becomes very important. And the metrics we still reach out for evaluating the systems are the ones that were actually built for different use cases, like the translation or generic similarity or summarization. And we need to address this gap. So here the question that we need to ask is actually, can we trust the answer enough to use it in production? And the question is no longer about can we get a model to answer from documents. And we cannot improve anything that we can't measure correctly. So yeah, the very common cosine similarity, I think every one of you would be knowing this. So what is cosine similarity? So it is basically the cosine of the angle between two vectors in a embedding space, which actually tells if two pairs of text, if they are semantically similar or not. And we use embedding models that are trained to actually capture the topical similarity, but they do not actually capture the logical entailment or the factual truth. They just capture the similarity. And here, as we saw earlier in the example about the nominated beneficiary and legal heir, how the roles were swapped, but the similarity, it still was very high. So it is actually wrong, and it did not take into account the meaning. It was just looking at the similarity. Now let us look at the BLEU, Rouge, and BERTScore. So BLEU asks how much of what was generated overlaps with the reference, and this was built for machine translation. And it is actually based on the n-gram precision style. Then we have Rouge. It actually asks how much of the reference was actually covered in the generated answer, and this was built for summarization purposes. And these both actually work by seeing the overlap of the words that we have between the reference and generated answers. And they actually penalize the valid paraphrases, and they reward the copied words. And then we have something that is improved, that's the BERTScore, but which actually gives us the contextual embedding similarity, and it is actually able to handle the paraphrases, and it is actually better than the n-grams that we see in BLEU and Rouge. But again, it cannot tell whether it is if it is factually correct or not. Again, it relies on the similarity or the meaning. Now, this slide is actually the core of the whole talk. So here we have a reference answer. Only the nominated beneficiary can file a claim on behalf of the deceased policyholder, and then we have 3 candidate answers. So first one says only the legal heir can file a claim on behalf of the deceased policyholder. Again, here we see the swapped role, and our similarity metrics are still high. Then another is where it says any family member. Again, this is wrong, but the cosine similarity and Rouge, they are still high. And then there's another paraphrased version which actually rephrased the whole wording, but the meaning is same. But then the scores are really low for that. So, and also I just wanted to highlight here that these are all the illustrative scores that actually might vary by the embedding model that we use. But here we can see that both the answers, the first and second, they both are wrong, but they still score high. And the correct paraphrased one, it gets the lowest score. So, and these metrics actually, they tend to reward lexical overlap and not the correctness. So, so for the RAG system, we need to actually decompose them into 2 failure modes. One is the retrieval failure and another is the generation failure. So, retrieval failure actually tells us whether right chunks were retrieved or not, or only wrong chunks were retrieved. So, and then these would not contain the answer to our question. And then comes the generation failure. So, there can be cases where the right chunks are retrieved, but still the LLM hallucinated into giving the wrong answer. Now, these are independent problems that we need to solve independently, and there can be cases even where wrong chunks are derived, and then our generator model, it actually goes ahead and gives us the correct answer, which can actually happen because there would be some examples or some data from the pre-training of the model that it actually knows, and hence gives us the correct answer. Now, so here we need to decompose them into 2 different problems, because if we do not, we cannot tell exactly which component failed, and hence we cannot debug the system properly. Now, these are the retrieval metrics, and they are pretty easy to reason about when we separate them from the generation metrics. So, I would like to talk about the context recall and context precision. So, context recall is basically tells us like of all the chunks that we need to answer or that are relevant, what percentage did we actually retrieve. So, say if there were 3 chunks that were relevant and we just retrieved 2, that is an incomplete recall. Then we have context precision, which tells how many of the relevant chunks that we are retrieved. So that tells us the context precision. Now, these metrics, they measure the retriever. They do not tell us like whether the generator that's using them did it use them correctly or it hallucinated. So for that, we have generation metrics. So these are the three metrics: faithfulness, answer relevance, answer correctness. So faithfulness tells whether the answer that is generated, whether it and the claims that it makes, is it supported by the retrieved context. So and then answer relevance is whether the answer that is generated, does it actually answer the question, or is it hallucinating, or whether it is just giving, or whether it is just has generated answer for a wrong topic. Then we have answer correctness. So here we actually compare the answers with the ground truth or the expected answer, and which tells us whether they are correct or not. So the takeaway here is, when we combine this with retrieval metrics, these helps us to debug very easily, and also makes the system very explainable to the builder, whoever is working on these. Now let's see an example of the decomposition in action. So here's the question: what is the recommended dosage for children? And the retrieved chunks are, the doc one says adult dosage, and the other one says side effects, and then the LM generates its answer. The recommended dosage for children is 10 mg daily. So, and then we can reason through the metrics that we have. Here we see the context recall is 0 because the retrieved contexts are not relevant here. Then again, context precision is 0 because the whatever context that we have retrieved, it is not relevant in this case. Faithfulness again is 0 because the generated answer is not supported by the retrieved context. Then we have answer relevance, which is high because at the end, the answer that is generated, it does address the question that is asked. But the answer correctness is again 0 because it is simply wrong. So we can see here how the retrieval failure actually cascaded into a answer hallucination, the generation hallucination. Now we need to fix the retriever, and this actually helps us debug that we need to fix the retriever so that we fix the issues that are coming downstream. Now, talking about LLM-as-Judge, we need to replace the surface metrics with semantic judges. And this is where LLM-as-Judge comes in. So we know what to measure, but how do we measure it? So we have, we can measure faithfulness, relevance, correctness, which are different from the n-gram or embedding distance, and we cannot use them for measuring these. So we need LLM-as-Judge in this case. And here the judge would read the question, the context, the answer, and sometimes also the expected answer or the ground truth answer, and make a semantic judgment, and not just the pattern match. Now this also needs a nuanced criteria on how and what all things that we need to evaluate this on, and along with this we also need to carefully give the evaluation criteria and make it make sure that there are no biases. So GEval is something that improves on the naive LLM judge. So naive LLM judge would say, or we could give it a prompt like, just read this answer from 1 to 5, and which would just give us a hard integer, and again this would make the model give us something vague or inconsistent scores, and we cannot rely on that. So GEval actually upgrades on this. So one is a chain of thought. So in this we actually provide it a detailed criteria and anchored scale, and then LLM reasons step by step through the whole process. And then we know whether, and then we can also give it anchored examples like how, like what score of 1 looks like and what score of 5 looks like. So yeah. And then there is something probability weighing. So depends on the model that you use, and if it gives away the log probes, and we can use the log probes to produce a normalized continuous score. Like instead of giving just a hard integer of 4, it would give us like 3.85, and it actually helps us to capture the uncertainty if there's any. So again, a takeaway here is good judging, it does not come from just using a strong model. It comes from giving the model precise criteria so that we know exactly if it is able to evaluate the things properly. Then there are two ways LLM-as-Judge. There are two ways we can use LLM-as-Judge. One is pointwise. So here we would score the answer on its own from a scale of 1 to 5. And it is actually good for tracking a single metric over time or debugging any individual failures. So say, for example, we chose to track factual correctness over time in a monitoring dashboard. So this would help us. Then there's pairwise evaluation. So here we would compare two answers, and then we would pick a winner. And this is actually more reliable for A/B testing. And as we know, like humans and LLMs, they both are actually much better in relative judgments than giving absolute scores itself. Also, pairwise evaluation is more useful when we want to compare two models to context or two prompts. So we can actually use pairwise evaluation there. Now, yeah, so going forward. Now, just using a strong model and just giving away the evaluation criteria is not enough. We need to also have a better quality of the evaluation criteria, wherein we actually tell it what factual accuracy, completeness, or relevance actually looks like, and how, and if there's a, say, if it generates an answer, we should tell it that a score of 1 would mean that the claim in the answers are not at all supported, and a score of 5 would mean that every claim in the answer is fully supported by the retrieved context. So we need to define each term properly. Then we can also anchor it with examples, like I said, like score of 5 looks like this and score of 1 looks like this. This helps us to calibrate the judge. So that we know that we are getting correct responses or correct evaluation from it. Then there's another thing that we can do is we can evaluate a single answer that we have generated and give it as input through the judge multiple times, and if the scores keep on changing, that would tell us that our criteria is ambiguous, and we need to improve on that. Now, which model should we use? So we can use any strongest frontier model that we can afford, because at the end of the day, we do not want our production systems to be hallucinated or failing. So, and also they are less prone to biases. Now, there's one more thing. There's another rule that we need to follow. We should never use the model for evaluation from the same family as of the generator model. Because it gives us the self-preference bias, and it tends to like the output from the same family because it recognizes its own wording and reasoning style. Now, we did use LLMs to evaluate LLMs because the older metrics didn't work, but even LLMs have biases, and if we do not address them, then we have just swapped the old metrics, those were broken, for the biased ones. There are three biases that I would like to talk. One is the position bias. So in pairwise pairwise evaluation, LLMs prefer whichever answer actually is positioned first. Then there is verbosity. So judges actually, they tend to reward an answer even when the extra length is actually adding any extra information. So yeah, and then there's self-preference that I talked earlier. So judges, they tend to rate output of their own model family higher than the equivalent answers from other models. And if we do not control them, we may once again be building something, a confident evaluation system that is again quietly misleading us. So we need to address those things. I'll talk about position bias. So how can we mitigate them? This is very easier one. So say there is answer A and there is answer B. So we position the answer A first, and then we compare, and if the judge picks up A and it gives it a good rating, that means answer A was better. And then if we swap and answer B is placed first and answer A is placed next, that means, and then again it picks up answer A, that means A was genuinely better. But if it picks up B, that means there's something wrong and we should take a look. So yeah. Then there's self-preference and bias, and this is trickier. So and there are two mitigations that we can follow here. We can use cross-model judging, that is generate with one provider, say you generate with Gemini and then use another model. So probably you can use Opus or GPT models to evaluate it. There are other model sets that you can choose from. And then there's another multi-judge ensemble that we can follow, wherein we say like we take 3 judges from different families and then we average the scores. And these would be like independent scores that we would be getting, though the cost would be higher in this case, but it is actually the most robust way that we can implement. Now again, we need to, now just mitigating this and is fine, but we need to calibrate it against humans also. So we take a sample of examples and we take the scores that are from LLM-as-a-Judge and from the human evaluations, and we then compare them on the same criteria and check if it's drifting away or not. And here at the end, the goal is to understand whether the judge is actually aligned enough to be useful. So yeah. Now I'll talk about why the normal test sets usually fail. So many of us, we would rely on the production data set that we have, wherein the user actually is asking questions and those are getting logged, and we tend to use those only for creating the test data, and those are actually well-formed questions. They are usually answerable, and yeah, we are not able to capture any other variations of those. And the failures that actually happen, they do not happen with these questions, they actually happen with the edge cases. And for that, we can use negations, multi-hop reasoning, false premises, retrieval gaps. So these are all the variations that we can extract out from those. And yeah, so we actually, at the end, we need examples which are designed to expose failure modes and just not tell that everything is looking really nice and we can just move forward. So, so these are the adversarial test techniques that we can use for building the data sets. There are two here, these are easiest, like negation injection and entity swapping. So talking about negation, the retrieved context might have something like the drug is approved. Then we actually go ahead and build something like build a question or get a question which says, is the drug unapproved? So this would help us handle the cases wherein we the logical negation and not just keyword matching. So we would be able to know if the model is able to handle all these. Then we have entity swapping. So so this has basically things like that are similar, but they are not wrong. So we would have something in the context like Paris is the capital of France. Then we ask a question, is Rome the capital of France? So this test case would tell us that the model is able to read the context properly, and it is able to also use that into generating the answer and not just doing any pattern matches on the topic. Next is multi-hop reasoning and counterfactual question. Multi-hop reasoning is basically where we design the question which has information combined from multiple chunks. So we know it is able to handle that properly. So question is, so the chunk 1 that we have is company Y, acquired startup X. Then we have chunk 2, Mike is the CEO of company Y. And then the question that we ask is, who is the CEO of the company that acquired startup X? You can see it, the question that is framed, it is from both the chunks. So the answer should come out to be Mike. So, and this will actually help us test whether the generator is able to connect the facts across the retrieval. Then there's counterfactual questions. So here we assume a false premise. So if we ask a question, when did the discontinued product launch, when in reality it was never launched, and the correct answer in this case it should give is the product never launched. And this would help us test the model if they can reject any false premise instead of hallucinating into a date and just tell that if nothing is available, so it should just give out that output. Then we have retrieval gap targeting. So there can be cases where the answer is just not available in the corpus. And say, for example, we ask it a question, what is the product roadmap for Q3 2027? Now, this is a future scenario and it is not documented. And the correct answer in this case, it should give out is, I don't have that information. So this would test the refusal behavior. And then we have near miss distractors, wherein the retrieved chunks, they are actually topically similar with what we have asked, but they are actually factually wrong. Like we ask it a question on the drug A or dosage Q, and then retriever fetches for drug A and drug B and some general guidelines. But then generator should pick up the right chunk and also ignore if there are any distractors in the retrieved context. So this would help us test the precision under noise and the production reality. And also in real systems, we all know that retrieval is often noisy and we do not usually get the correct chunks. So this is not an edge case, so I would say that. Now, how do we build and maintain the test set? So we start with representative production questions that we have, then we build adversarial variants from it. For example, negation, swap, multi-hop counterfactual that we talked earlier, and then we add the retrieval gaps as well as the near miss distractor examples as well. But then here we should, and then if there are any failures in the production, we should also add those failure modes to this so that we know that that we have not built a system that is just telling that this is all green and we are good to go. We consistently need to upgrade the test data so that we know whenever there are any failures. And so we need to keep the eval set challenging, that it reveals its weaknesses. We should not be just setting a benchmark and using that over time. And then we have two open source frameworks that we can use directly without building something on our own from scratch. One is Ragas and another is DeepEval. So Ragas is it is designed for the RAG metrics and it is RAG centered as well. So here for the retrieval we have the context precision, context recall, context relevancy, noise sensitivity. And for generation we have faithfulness, answer relevancy, factual correctness. And here how the Ragas actually calculate faithfulness is very intuitive. So it actually decomposes the answer into claim wise, and then it checks if the claim that is made in the answer, is it actually available in the context that is provided. So you can check that out, and then DeepEval is actually broader. Along with RAG metrics, it actually also gives us safety metrics, custom GEval metrics, or any other custom metrics, then conversational metrics, multi-turn evaluation that we actually saw in yesterday's talk. Then it also helps us with the CI integration, CI cell integration that we usually follow in our development. And yeah, so now evaluating many examples across multiple metrics, they would actually add up the cost for the judge very quickly. And but we still need to use some strong models so that we know that our systems are not failing. And here there are some ways that we can mitigate that. So one is prompt caching. So we can actually use the same instructions that we need to give to an evaluation model across sets. So we can just set them and we can reuse them. Then there is batch pay. If the latency is not a problem, we can use batch processing. Then there is hierarchical eval, as in use a cheaper model for cases where we know that yeah, this is a short failure case, and then use a strong model for cases where we know that yeah, this is where we need good reasoning, and then we use smaller sample during iterations that when we are developing, and then use full eval set just before the release. So here key takeaway I would say is the cost becomes manageable, and it is actually much cheaper than debugging any production failures that we get after deployment. So here's a eval stack that you can actually go through and would actually help you. So you should actually build a test set that has the representative questions, and then the adversarial hard variants that we talked earlier. And then we should actually use a labeled ground truth. Now this is a less glamorous part actually, but it is essential for comparing the generated answer with the reference so that we know everything is correct. Then we should run the RAG pipeline and get the answers and retrieve context, and then use RAGAs or deep eval and the metrics from those to evaluate those outputs. Then we should track the scores. And then log it by version or timestamp so that we know when was something that changed actually affected our metrics. And also we should always refresh our test data. We should not keep it stale. So all of this actually will make the evaluation part of the whole development process, of the whole product development loop, I would say. Then these are the key takeaways. So we should stop using the BLEU, Rouge, and Cosine Similarity usual metrics as our primary RAG metrics, and then we should decompose evaluation into retrieval metrics and generation metrics. We should actually look at the RAG evaluation metrics as a decomposition problem, and then LLM-as-a-Judge with the G-eval, it is the new standard that we can use. Then along with that, we should mitigate the judge biases that we talked, the position, verbosity, and the self-preference, and all can be fixed. Then we should build adversarial test sets, and we should always refresh them. And finally, we have RAGAs for RAG metrics and deep eval for broader eval, which we can also integrate with the CI CD. So yeah. Now these are some of the references that I referred for my talk. You can actually go through them from the shared material that I'll share. And then yeah, this is the link to the deck, and yeah, and you can actually reach out to me on LinkedIn, and I'll be happy to answer any questions.